Hi, my name's Ryan Olson. I'm a product design engineer who's been using SolidWorks for about 9 or 10 years now. And recently I've been experimenting with a relatively new software package put out by Autodesk called Fusion 360. I think this package has a lot of potential, but it does require you to think a little bit differently from the way we're used to thinking in SolidWorks, Pro-E, Inventor, packages like that. So with that in mind, I decided to put together this video series that shows the process of working through some modeling exercises in Fusion 360, specifically with a concentration on the way that some of the workflow and thinking changes for those of us coming over from a package like SolidWorks. So for this modeling exercise, I thought it might be useful to look at something like a very simple two-axis CNC machine. This is something that might be the basis for like a laser cutter or something like that. Certainly nothing revolutionary in terms of the design. It's very simple, but it gives us a lot of opportunities to look at different things in Fusion 360 related to the way that you would put together an assembly, the idea of mates or joints, and the whole idea of modeling in place, which is a big deal in Fusion 360. So basically what we've got here is a tool bed, a couple of shafts which define the y-axis, and along those shafts run this subassembly that's the x-axis carriage assembly. So it'll slide in the y direction. The sled on the x-axis assembly can slide in the x direction, and that allows the tool, whether it's a laser or mill bit or whatever, that's on this sled to move anywhere in 2D around the tool bed. We'll begin by defining a guide sketch, which will define the location of key components in our main assembly. We'll begin with a tool bed size approximately 600 by 600 millimeters. We'll also define two lines which will show us where the y-axis shafts lie with respect to the tool bed. We'll set these two shafts to be the same length. In this case, we'll be making these shafts from stock material we already have on hand, so it's our design intent for these shafts to be of a specific arbitrary length. We'll codify that design intent by setting up user parameters which define the length of these shafts. We'll define a new user parameter that represents the length of the y-axis shaft, and then assign the dimension from the sketch to use that parameter as its value. At this point, we want to set up the positions of these y-axis shafts so that they are centered between the front and back of the bed. So we'll set up some guidelines to do that. There are several ways to position these guidelines such that the y-axis shafts are centered between the front and back of the bed, but in this case, let's do it using a formula. We also need to define the amount that each y-axis shaft is inset from the edge of the bed. Normally I would do this with reference planes in SolidWorks, but in Fusion 360 it's easier to do this in a guide sketch, as you'll see later. Since I'll most likely be changing this as the design evolves, I'm going to favorite these two dimensions. This way they show up at the top of the list and I can find them easily. That's enough for this guide sketch for now. Let's go ahead and rename this guide sketch so that we can find it easily. The next step is to define a plane which will tell us how high above the bed the x-axis assembly resides. We can do this with an offset plane. Since this plane offset dimension is something that we're likely going to be changing during the development of the model, it can be useful to label that dimension. Now that we have a plane defined for where we want to put the y-axes, we can project our two y-axis position lines onto that plane so that the lines will be in the right place in 3 dimensions. We'll use the project tool in the sketch interface, which works a lot like convert entities in SOLIDWORKS. These 2 lines on this new sketch now represent where we want the Y shaft components to be in 3D. At this point we should start adding some components to the assembly, so let's start with the tool bed itself. There are a few different ways to create components in Fusion 360, so I'll start with the most basic, which is creating a body and then converting it to a component. We've now created a body at the top level of the assembly, but it's not yet its own component. By creating the component from the body is now absorbed into a new component, and the component is positioned where we want it. In this case, we don't want the tool bed component to move relative to the origin of the assembly, so we're going to ground it, which is like fixing a component in SOLIDWORKS. We'll go ahead and give this component an appropriate name and then hide it so that we can add the 2 y-axis shafts. We can now look at a couple different ways of adding the Y-shaft components. SOLIDWORKS users such as myself might be inclined to do it by creating a new component and then positioning that component within the assembly in the place that we want. And indeed, that is possible in Fusion 360, as I'll show here. We'll create a new component. We'll activate the component to make sure that we're working within this component. While we're dimensioning the shaft diameter, we should probably set up another user parameter, since this is something that could also change through the evolution of the design. Now that we have our profile sketch, we can extrude it to create a shaft of the desired length. We now have a component with its origin at the assembly origin that contains one body, which is a shaft of the proper dimensions. However, it's not yet positioned correctly in the context of the assembly. Since the component isn't mated or jointed to anything, we can move it freely within the assembly at this point. However, notice that once we do move it, we have the option to revert it to the original position or create a snapshot feature which will record the new position of the component. This will become very important later on. What we want to do here is to mate this component with the y-axis guideline that we created before. This can be done using a rigid joint. As you can see, we've got the location right, but the orientation of the joint is wrong. This is because the joint origins of this rigid joint aren't properly aligned. We can fix this easily by adding our own joint origin. The joint origin is now located where we want it to be, but we need to reorient it. Now that we have a custom joint origin in our assembly, it's an easy matter of mating the shaft component with that joint origin, which belongs to the parent assembly. This component is now rigidly jointed to the assembly and will follow these guidelines if we were to change them. We now want to place another instance of that component at the right-hand side Y-shaft location, which is simply a matter of doing a copy and paste. Control C, Control V. Now notice that I've moved it to approximately where I want it to be, but it's not yet jointed to this guide sketch. So if I were to change the sketch, the component wouldn't move in with it. We need to set up the proper joint. To do that, I need to set up a joint origin on this guideline as well. And now we can establish the joint. Note that I've moved it out of the way temporarily just so that it's easier for me to click on this, but I'll get a warning about the fact that I've changed the component's position as I do the joint. So this warning that comes up is basically just reminding me that I've manually moved this component from the position in which it was originally created, which was through that copy operation. And it's asking, do I want to put it back where it was in terms of the feature tree, or do I want to continue with where I've moved it from? And in this case, I just want to continue because I moved it just to be able to select it more easily. So the first component is the one that's going to move. I'm mating it to my new joint origin. And now both of these are in place. It is important to note that these are two instances of the same component. Even though I used a copy operation to create the second one, it didn't disassociate the second component from the first one. So what I've shown here is a good approach to take if you're used to modeling components separately and then later bringing them into an assembly. Or if, for example, you've already got a model from somewhere else, or you're working off a model that was made to represent stock material you already have. This method of bringing it into the assembly and then establishing a rigid joint to a guide sketch is a good way to go. However, Fusion 360 was really designed with in-place modeling in mind, and in a case like this, it can be a much more efficient approach to modeling. So I'll show how to do that next. Let's actually roll back here. We'll get rid of the shaft component that I had created, so I'll just roll it back and then say delete all features after history marker. And we'll go ahead and model this in place instead. Again, I have only one component, which is the tool bed. It's hidden right now. I'm working in the main assembly, and what I'm going to do is draw a sketch at this point and extrude it out to this point, therefore using the guide sketch to extrude the geometry. So the first thing I need is a plane. I can now sketch the profile on this plane. And I can extrude it out. A couple ways to approach this. I could either extrude it and use the to extent to go to this point, or I could extrude it at distance and type in my shaft length. It's basically going to end up with the same thing. More importantly though, if for my operation, I want to say new component, so that I'll be creating this body and a new component to hold it in one operation. So with that one feature, I've got a new component which has in it the body of the shaft at the proper dimensions. Now, even though we've modeled this component in place, it still actually isn't jointed to the assembly in the way that an in-place mate would lock down a component modeled in this way in SolidWorks. So it's simply a matter of adding what's called an as-built joint. So at this point I can still move the component around. It would remember the position and allow me to revert it, but I actually want a joint here. So we'll go up and do an as-built joint. And all I have to do is select the component and the parent component, which is the parent assembly, and click OK. At this point, the component is actually jointed to the guide geometry. And again, if we were to change anything about the guide geometry, the component would go with it. So for example, we could go and change the height of the Y shafts above the bed, and it updates accordingly. Now to create the shaft on the right-hand side, I could just create another component doing the same thing, but I really want these to be the same component. So I'm going to do the same copy operation that I did before and manually joint the second shaft to its location in the assembly. Control C, Control V. Set up our joint origin. In this case, it appeared to allow me to select the origin in the orientation that I wanted, so I'm just going to go with that. I will admit I don't totally understand how these joint origins are selected and manipulated yet. And And so you can see that I now have two instances of the y-axis shaft again in this assembly. So I think that's definitely enough for this video. In the next video, I'm going to show how we can start modeling some additional parts of these mechanisms, the sleds that slide along these axes, and the parametrically defined x-axis shafts whose length is determined by this guide geometry. So look out for that in the next video. Thanks for watching.